And that's what yeah, fine. So let me share my screen and then we'll start. Once you're able to see my screen, please confirm.
Yeah, I can.
How about the white screen? Yeah.
Yes.
Okay. Now let's first look at the basic concept around similar triangles. What we learned by similar triangles is two triangles where they have matching angles, meaning this triangle has one angle for which there is a corresponding matching value. So let's say if this is 60°, this is also 60°. Okay. Second, equally same way, second angle also has a matching angle. Let's say if this is 70°, then this is also 70°. Either this one of the two remaining angles. Okay. And the third angle will be what? 50°. So the total is 180. So third angle is 50°. So basically, two triangles are similar if they have matching value of the angles in each triangle. So if this has 60, 17, 50, this also has 60, 17, 50. Which one is 60, which one is 50, doesn't matter. It can be in the same sequence, reverse order, doesn't matter. Okay. But if this has 60, 17, 50, the other triangle also has one angle is 60, one is 70, one is 50. And that is when you call both the triangles as similar triangles. Clear? Let's say this is A, B, C, and this is D, E, F. Okay.
Okay.
So let's say angle A is 40°. Okay. And angle D is also 40°. Okay. It is not a similar triangle yet. We have found one angle is matching. Let's look at the second angle, angle B. If this is, let's say, 60°, and angle E is 60°. Oh, we found one more matching angle between the two triangles. So one is 40, here also we have 40. One other angle is 60, here also we have a 60. So two angles are matching. Now, for the two triangles to be similar triangle, the third angle has to be also matching. Meaning, there should be one matching corresponding angle in the second triangle also. Now, if you have 140 and 160, here also you have 140, 160. Will the third angle match between the two
Yeah.
triangles? Yeah,
Yeah.
it will, right? Because the sum of all the angles in the triangle has to be 180°. No matter the angle, triangle is small, big, isosceles, equilateral, uh, obtuse, acute, whatever it is. The sum of all the angles will be 180° for a triangle. So if the two angles are matching between two triangles, meaning the third angle will match, right? It is like this.
Can you repeat the thing?
Okay, so it is like this. So the first triangle has three angles, A, B, and C. Yeah.
Yeah.
Okay. Sum of all the angle will be 180°. Second triangle has D, E, F as three angles. Okay. Again, the sum of the all the angles in the triangle will be 180°. Yeah. Right. So this is A, B, C. This is D, E, F.
Okay.
Yeah. So here between these two triangles, we found that angle A and angle D are matching, meaning this angle and this angle are matching. Okay.
Okay.
We found angle B and angle E also matching. Okay, this is E. These two are matching also. Now the question to you is, will these two triangle angles match?
Yeah.
It has to match, right? Because sum of the three angles is 180 in both the case. And two angles have already matched. Okay, meaning the third angle has to match. No doubt about it. Okay, in a triangle. Yeah. So let me make a simple statement here. If you're looking at a triangle, if you look at two triangles, okay, and the two angles have matched, meaning third angle will match by default. Okay. So this angle and this angle have matched. This angle and this angle are equal. Okay. That means the third angle will be equal to each other. Am I confusing you? I'm just thinking.
No, you're
No,
not.
clear, right? Okay. Okay. Now
Yeah.
I'll keep asking you as many times till I get comfortable that yes, I'm making sense. Okay. These two angles are matching. This angle are matching. Third angle will match by default. Okay. Any triangle, any pair of triangle. Okay. Because sum of the all the angles is 180 always. Okay. So two angles have matched, meaning sum of these two angles are equal. This plus this equal to this plus this. Okay. So this one has to match, no question about it. Okay, because the total sum is this. Now let's come to the Pythagorean theorem. This is a right angle triangle. Okay.
Yeah.
What I did was I have drawn a perpendicular line from here, this corner to this line. Let's say this is A, B, C, and this is 90 degree. Okay. Now look at two triangles A, B, C. Come on. Triangle A, B, C and triangle A, B, D. Okay. I would, if you have a notebook and a pen, I would suggest you draw these two triangles on your notebook.
Okay.
Okay. Now you tell me, what do you see between these two triangles, ABC and ABD? ABC is the full triangle, this one, right angle triangle. Now ABD is the smaller triangle, here, this one. What do you see between these two triangles, ABC and ABD?
The size.
The side
Area.
AB, the side AB is common, right? In both of them. Yeah.
Yeah.
AB is common in both of them. Another thing that you see is this angle is also common in both of them, right? The angle A. Yeah. In the smaller triangle also this angle is there. In the bigger triangle also this angle is there. Yeah. Do you see that?
Sorry, my mic wouldn't turn on.
Okay. No, no. What I'm saying is between the triangle ABC and triangle ABD, meaning this triangle and the bigger triangle. Okay. What are the things that you see? Okay. First is this side AB is common, right? This side is there in both the triangles. Yeah. Agree?
Yeah.
And then this angle is also common between both the triangles, the smaller triangle ABD and the bigger triangle ABC. Agree? You keep your mic unmuted actually, okay? So that you don't
Okay.
have, yeah. So between these two triangles, ABC and ABD, side AB is common in both the triangles, correct? And this angle A, this one, meaning this angle, is also common between both the triangles, right?
Yeah.
Now comes the interesting part. Okay.
Okay.
See here. This angle we found is common in both the triangles, right? The smaller triangle ABD and the bigger triangle ABC. Now, in the smaller triangle, if you see, there is one angle. This angle is 90 degree. Do you agree? Because
Yeah.
we have drawn a perpendicular line. So this is 90, this is also 90. Okay.
Okay.
Now, I think Mithran also joined.
Hi.
Hey, Mithran. So,
So,
Mithran,
so what were we learning while we were gone? While I was gone.
no, so we were just doing a recap of similar triangles and we were trying to get our journey started with how do we prove the Pythagorean theorem. Okay.
Okay.
In today's class, we'll only prove Pythagorean theorem, nothing else. Okay.
Okay.
So, Mitran, one request I have for you. You
What?
have puja at home, right?
Yeah, I did.
I want you to bring prasad for me tomorrow.
Okay.
Me and Arna both.
But I don't know. I don't know. Okay.
Bring some dry stuff. No, not anything which is liquid. Okay.
Okay.
All right. So yeah, uh, coming back to this one. Okay. So I was just revising based on what we have learned so far. What is a similar triangle? Two triangles where they have matching angles. That is called similar triangles. Okay. This angle ABC and angle DEF. If we say these are similar, that means one angle of this triangle is equal to another angle of this triangle. Okay.
Okay.
Second angle of this triangle is matching with second angle of this triangle. Okay. And if these two angles are matching, third angle will match by default. Do you know why, Mitran?
Um. Why?
Because sum of all the angles is 180 degree. If two angles have already matched, third angle has to match because it will be 180 minus the two angles, right?
Okay.
So it's like this: 10 plus 10 plus 80 is 100. Okay, let's say.
Mhm.
Now this 10 and this 10 have matched. Okay,
Okay.
so this 80 and this 80 also has to match, right? Yeah, if the sum is same. Because in case of triangle, what happens? Sum of all the angles is 180. Yeah.
Mhm. Okay.
So angle A plus angle B plus angle C in the first triangle is 180 degree. Yeah.
Mhm.
Angle BD plus angle E plus angle F equals 180 degree. Both are triangles, right?
Mhm.
As per similar triangle, I said first angle and angle A and angle D are matching. So these two are same.
Okay.
I said angle B and angle E also matched, meaning angle B equal to angle E.
Okay.
Okay.
So angle C and angle F have to match. They have to be equal because sum of the three angles is equal to 180. And if two have matched, third has to match so that it's always 180. Yeah.
Mhm.
Are you guys confident or not?
Yeah.
Yeah.
Yeah. Okay.
Yes.
Yeah. Yeah. So again, you never have to say yes just to make me feel happy. I will keep bugging you, nudging you till I feel that yes, you guys have followed me. Okay.
Mhm.
Now,
Okay.
now I am going to jump onto the Pythagorean theorem. Okay. How do we prove that? Okay. So
Mhm.
before we do that, okay. Now one question: if these two triangles, come on. If these two triangles A, B, C and triangle DEF, if they are similar triangles, meaning A and D are matching, B and E are matching, C and F are matching. What happens is thus, as per the property of similar triangle, what we have learned is side opposite to the matching angles will be in the same proportion. That's what we learned in the last class. Meaning side opposite to angle A is what? BC. So BC divided by the matching angle is D. What is the side? EF. BC by EF equal to second angle B. What is the side opposite to that? AC
Okay.
divided by next matching angle is E. Angle matching to B is E. What is the side opposite to this? This is DF. DF
Mhm.
will be equal to the third angle's opposite sides. So angle C opposite side is AB. AB divided by this angle is matching to C. So what is the side opposite to that is DE. This is what a property of similar triangle says, that if two triangles are similar, the sides opposite to the matching angle will be in the same proportion. Okay.
Okay.
So this is the proportion of the matching angle A and D. This is the match proportion of the sides of the matching angle B and E, meaning the sides opposite to these angles. Okay. This is the
Okay.
proportion of the matching opposite sides of the matching angle C and F. Yeah. This is the
Okay.
problem. This is what it says. If two triangles are proportional, two triangles are similar, the sides opposite to the matching angle will be the same proportion. This is what it is. Okay, this is the property. Now we'll use this property to prove the Pythagorean theorem. Okay. Now,
Okay.
what is the Pythagorean theorem? It says a square plus b square equal to c square, where a
Okay.
and b are the adjacent sides for the 90 degree, and c is the hypotenuse. This is the Pythagorean theorem, correct?
Okay.
We are trying to prove that here. Let's do it. This is the right angle triangle A, B, and C. What we'll do is we'll draw a perpendicular line from here to opposite side. Let's say it cuts here at point D. This is 90 degree, this is 90 degree. Okay. And this whole angle is 90 degree. Okay. So
Okay.
ABC was a right angle triangle for me, for us. What we did was we picked point B and we have drawn a perpendicular line to AC. And it cuts here at point D. Okay. So this is 90 degree, this is 90 degree. Okay.
Mm-hmm.
Any doubt so far? No?
No, no
Okay.
doubt.
Okay.
No.
Now we are going to use the same property of similar triangles, okay, to derive the Pythagorean theorem. So I'm just trying to find out what are the similar triangles we have here. Now look at triangle ABC, the first triangle, and let's pick up this triangle, the small one, ABD. So triangle ABC and triangle ABD. Okay.
Okay.
So ABD is this one, okay, the small piece, okay. A, B,
Okay.
and D, yeah, and ABC is the full triangle. Now between these two triangles, what do you see? This angle is common. Angle A is common between these two triangles, right?
Mm-hmm.
Yeah.
Yeah.
So one angle is matching between the two triangles, okay, ABC and ABD, okay.
Mm-hmm.
Now look at this second angle, angle BDA. What is the value of this angle? 90 degree, isn't it?
Mm-hmm.
Don't say you have to say yes.
Yeah.
Yes.
Because when you say it looks like you are thinking, okay, and that is where I get worried. Okay.
Okay.
So in this triangle ABD, this is 90 degree because we have drawn a perpendicular from here to this line, right? So this is 90 degree, this is also 90 degree. Okay. So if you are looking at this triangle ABD, this angle BDA, meaning this one, which I have colored in black right now, this is 90 degree. Yes.
Yes.
And how about the angle ABC in the bigger triangle? ABC. This is 90 degree, right? Because this was a right angle triangle. That's what we had picked up, correct?
Yeah.
So between the triangle ABC, the bigger one, and this smaller one, ABD, two angles have matched because angle A is common and this is 90, this is 90. What is remaining is this angle in this ABC, meaning ACB, this angle, right? The one in the corner in the larger triangle, and this
Yes.
angle
Okay.
here, and the smaller this angle here in this ABD, the one which is at the top here, this one, this piece. Yeah,
Yes.
these two angles will also match, isn't it? Why?
Yes.
Why? I'll make you think. Arna and
Can
Mitra.
you like repeat the question?
Okay, so let me clean out the dirt from the image. Okay, this is too messy. Now, what I did was, this is my first triangle, right? Right angle triangle ABC. Yeah.
Yes.
What I've done is I have drawn a perpendicular line from point B onto the line AC. Okay, which is cutting this line at point D. Okay, meaning this angle and this angle are 90-degree. Yeah.
Yes.
So basically, I'm talking about two triangles right now. Triangle ABC, which was my first right angle triangle from where we had started. Yeah, where the angle B is 90.
Yes.
And I'm
Okay.
talking about second triangle ABD, which was one of the child triangle that was made by joining these two lines. I mean, joining these 2 points, meaning drawing the perpendicular from point B. So I got two child table ABD and this child table, right? BCD. So I'm looking at the first child table ABD, okay, and the m- child triangle ABD, this one, and I'm looking at the parent triangle ABC, okay. In these two
Oh,
in these two triangles, I'm trying to find out some relationship. What we found was this angle was matching in both the triangles, right? This is common. Angle A
yeah.
there in both the triangles. And we found that this angle, which is 90-degree, meaning angle ADB or BDA, whatever you call it, this angle, okay? This is 90-degree in the child table triangle, and this angle, this one, ABC, okay? This is 90-degree because this is right angle triangle, okay? So this angle is common. This angle and this angle are matching between these two triangles, okay? Will the third angle match? Meaning the angle ABD and angle ACB. Are these two equal or not? That's what I want to know from you. And if yes, why?
B. Wait. A. D. A. B. D. A.
Um,
I think
it's
I think it's not the same because the first one's an acute angle
yeah,
and the second one's right angle.
No,
but
so
the numbers like my okay, never mind.
mm, think one more time. I'm just see, I don't know the value of the angles also. Okay. I just know then in the larger triangle ABC, angle B is 90-degree. Okay, because this is a right angle triangle for me. And angle AS ADB or BDA, whatever you call it, this angle is 90-degree. Okay.
Oh, wait, I think they're the same. I think I must have read it, seen it
Yes,
wrong.
yes,
Yeah, that's what I said before. I
that,
said that before.
that's the same. That's what I see. See,
I think
I was
I must have read it wrong. I should have looked more carefully.
not. You guys are fine. See, trust me. I would have gone more wrong if I was your age. Okay, so don't worry about that. These two angles are same actually. Why? Because this is common and one other angle is 90-degree, which is matching in both the triangles. Okay. So the remaining value of the angle will match. So simple thing to remember is if you are talking about two triangles and two angles have already matched, third angle has to match by default. Yeah. Because sum is always 180. Yeah.
Yeah, okay.
Now, now whatever you guys said or agreed, same formula applies true if I look at a different combination of triangles again. In the same triangle, let me, okay. Now I change my plan. Okay. I have the same right angle triangle ABC. Okay, from where point B I have drawn a perpendicular line. So I have this 90 degree and this is 90 degree. So I change the plan. I am looking at these two triangles now, ABC and triangle. Before I go there, now tell me, based on whatever you guys saw, can we say that triangle ABC and triangle ABD are similar triangles?
Um, yeah, they
Because,
are.
yeah, because the three angles are matching, right? They both have same value for three angles, correct?
Mm-hmm.
Anna, you agree?
Yeah.
Okay. Now comes the change in the plan. So now what happened was this. I had a we had a right angle triangle ABC. What we did was we just this was 90 degree. What we did, we took this point and have drawn a perpendicular line on the opposite side, which is cutting at point D. And what we found that this small triangle ABD became similar to the original triangle ABC. So triangle ABD was similar to triangle ABC, the parent triangle. Yeah, this is what we saw.
Mm-hmm. Yeah.
Now there's one more triangle, one more child triangle, right? BDC, triangle BDC. And if you look at this triangle against triangle ABC, the parent triangle, meaning, so there are two child triangles, right? That is made. And this is my parent triangle, ABC. If I look at the second child triangle, BDC, meaning this part of the triangle, this one, this colored portion, right? This child triangle against the parent triangle, ABC. Do you find that this triangle is also similar to the parent triangle, like the other one?
Hmm.
Think. I'm I'm making it simple. Triangle ABC and triangle BCD. Are these two triangles similar? This if we use the same approach like what we did for the first one.
A, B, C, B, C, D, A, B, C.
So what do you observe here? See, I'll give you some clue. First of all, this is a angle common between both the triangles, correct?
Yeah.
Yeah, angle
Mm-hmm.
C is common, right? So one
Mm-hmm.
angle has already matched for you, okay? Between the parent table triangle ABC and BCD. This is a common angle. So common angle has to match, no question about it, right? It's the same angle actually. Yeah. One
Okay.
angle is already matched. What is the second angle here? 90 degree because you have drawn a perpendicular. This is 90 degree. This is 90 degree. So between the small triangle, this one, and the bigger triangle, this one, two angles have matched.
Mm. Okay.
So third angle will
Mm.
also match.
Match with the other two.
Yeah. The other two angles will also match.
Yeah.
That means the second child triangle is also similar to the parent triangle.
Okay.
Agree or you don't agree?
I
Yes.
agree.
Yeah. You're able to relate also, right? So what's happening here? See, if you look at, oops, come on, let me clear it. Okay. So basically, what is the conclusion from whatever circus we were doing so far was this. If I have a right angle triangle, if I draw a perpendicular line from this point to the other side, it makes two child triangles, this and this. And both the child triangles are similar to the parent triangle ABC. ABC. So I can say this is ABC, and let's say this is D. So I can say triangle ABC is similar to triangle ABD, and I can also say triangle ABC is similar to triangle BCD. Can I say so? This is what we
Mhm.
saw, right, so far? That this child triangle is similar to the parent triangle. This child triangle is also similar to the parent triangle ABC. Yeah, because we found matching angles, common angles, then we found the other angle is 90 degrees, the third angle has to match. That this is what we have seen so far.
Okay.
Arna, you are with me?
Yeah.
Okay. Simple summary is when I have a right angle triangle, I pick the corner where I have a 90 degree. From there, I draw a perpendicular line on the opposite side. The two child triangles that are made, they are similar to the parent triangle. How is what we saw just so far. Yeah.
Yeah. Okay.
This is what helps you prove the Pythagorean theorem. Now you'll say how. Yeah. So
Yes.
let's look at it. A, B, C. And this is D. So first thing we saw was triangle ABC is similar to triangle ABD, the first one. Okay. Now, when the triangles are similar, meaning the ratio of the sides are in the same proportion. Okay. Meaning, now let's look at this angle. What is this angle A? A is common here, right? Between the small triangle and the bigger triangle. Which side is opposite to angle A? Let's say if I'm taking the smaller triangle first. So side opposite to this is BD. Okay. So BD divided by, look at the bigger triangle. What is the side opposite to this one? This is BC. BD by BC will be equal to, look at the second angle, 90 degree, let's say,
Okay.
in the smaller triangle. What is the side?
Okay.
AB.
Yes.
Look at the bigger triangle. What is the side opposite to this one? Is AC. Yeah.
Mhm. Yeah.
And the third one is this small angle here in the small triangle. What is the side opposite to that one? That is AD. Okay. And
Yes.
this angle equal to this one is this one in the large angle, right? This and this are the remaining angles. So side opposite to this one is AD divided by the same I mean matching value angle is this one in the larger triangle. It will be AB. Yeah.
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 Now look at the second triangle, meaning uh, AD by AB. Okay. So now look at this second triangle, this one, BCD and the larger triangle ABC. Okay. What is the, I have to make this little clean. This is looking so dirty that I can myself cannot make out much. So let me clean this. So we have got one formula so far. Okay. This based on the two triangles A, B, C, and this is D. So based on ABD and ABC, this is the formula we have got. Now look at second triangle ABC and similar triangle. The second child triangle is BCD. Okay.
Okay.
Here also look at the matching angles. This angle is matching in both the common in both the triangles, right? So side opposite to that. So let's say side opposite to that here in the small triangle will be BD divided by same side will be AB. Okay.
Okay.
Now look at
Okay.
second angle. Second angle is this one. That is BC, side opposite to this one is BC, this one. BC divided by the matching angle in the large triangle is this one. So the side will be AC. Yeah.
Mm.
And the third angle is this one in the small triangle. The side opposite to that will be CD. CD divided by the side, the matching angle for this one is this one. So side opposite to that is this one, BC. CD by.
Yeah, okay.
So can I request you guys to write down this equation? The first equation, write this one, okay? Eight,
The A.
just
Okay.
write it down as AD by AB equal to BD by BC equal to AB by AC.
Okay.
Let me also write it down so that when I'm doing calculation, because once I clean this screen, okay. No, I can go to another screen. Okay, fine. I will have it here. Okay, now, okay, I have a solution now. So tell me AD by AB equals BD by BC. BD by BC equal to AB by AC. I'm just noting down from the previous screen, okay? AB by AC.
Okay.
And the second one is CD by BC. CD by BC equal to BD by AB. BD by AB equal to BC by AC. By AC. Now, here, okay. Hmm, okay. Now, this is my triangle A, B, C, and this is D. Okay. So, this is the problem. I have to get a um, notebook. Otherwise, I will get you guys confused. Okay. Now, look at this. Remember this one, okay? I would want you guys to write down something. Okay. Can you do that quickly for me?
Okay.
You want us to write it?
Yeah, I want you to write it.
Okay.
Write this one. AD by AB equal to AB by AC. Write it down. AD by AB. This one. This is equal to this equal to this. So I'm just not writing this one. I'm just saying AD by AB equal to AB by AC.
I'm done writing.
Okay. Now look at
Same.
this one and this one now. Okay. CD by BC equal to BC by AC.
I finished writing.
Okay. Now you guys tell me what is that you have written.
I wrote. Wait, did you only tell us to write AD by AB and AB by AC? Just the letters?
AD. Yeah, just tell me what you have written. AD by AB.
Yeah, AD by AB equals to AB by AC.
Okay. What was the second one?
CD by BC equals to BC by AC.
Okay. Now look at these two formula. Okay. Whatever we have written. How will you simplify this? Can you say AD into AC equal to AB into AB? Can you say that?
Yeah.
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 From this one, I have just simplified this, right? This is how this goes upward, this goes this way. Okay. So this is how they move. I'm making this guy go this side, so this goes up. And this guy come this side, this goes up from here. Okay, so AB into AB will be AD into AC. This is fine. So
Yep.
I can write this as AD AB into AB, meaning AB square. Let's say AB is what? A, this was B, and this was C. That is what the Pythagorean theorem says, right? As per the Pythagorean theorem, this is A, this is B, right? So I'll replace this AB with a, or okay, let me not confuse you guys. Let it be like this. Okay. Now here, I'll have to probably write in a smaller font so that I can make better use of the space. So here, AB into AB, AB square equals AD into AC. AD into AC. This is one. Okay. One.
Okay.
Now look at this guy. Here also same thing. I'm simplifying this. So this goes up, this goes here. So here BC square equals BC into BC square. This goes here, right? So BD into AC. Okay.
Okay.
Now here, what do you see here? If I add these two, so if I'm just okay, cleaning up this place, okay, because you guys have already noted down. Okay, I'm using this place to do some more calculation. Okay,
Okay.
so what I'm doing now is I have AB square equal to AD into AC, yeah, and BC square equal to BD into AC, yeah.
Mm-hmm.
I just wrote it above, okay,
Okay.
so, so that I can do the calculation underneath. Okay, now
Yeah.
if I want to add these two, okay, I want to add this equation and this equation. If add these two, meaning if I say AB square plus BC square, what will be the value of that? This plus this, yeah.
Yeah.
Meaning it will be AD into AC plus BD into AC, yeah. I just added them. That's all. Yeah. AB square is this, BC square is this. I just added them. If I add both of them, AB square plus BC square, that is equal to AD into AC, that is have here, and BD into AC. Yeah.
Okay. Yes.
Now, can I say, let's see what is common here. AC is common, right? So I'll take AC here common. Then what I'm left with? AD plus BD. AD plus BD. AD plus BD. Hmm. This is not solving the purpose. Did I miss something here?
No. Wait,
Oh,
wait, wait. Should I write down that one that you just wrote?
yeah, yeah. Um, oh, AC. Okay, I think I made a mistake. CD. It's not BD. It's CD. That's why I was thinking what has gone wrong here. Second equation, right? It is BC square equal to AC into CD. BC square equal AC into CD. This is what where I was going wrong. That's why I was thinking why the equation has gone wrong. Yeah, if you look at this one, right? Here we pick this one and this one, right? So CD by BC equal to BC by AC. So BC into BC will equal to AC into CD. So AC into CD, CD into AC. This is what it is. So this is where I was going wrong. And I was thinking what I'm teaching you guys. Am I going wrong? So I know this is sounding little complicated, but I will come to that. Okay, I'll explain you guys. So this equals this AD into AC, AD into AC plus CD into AC, CD into AC. So between these two, I can take AC common, right? AC is common in these two, right? So it becomes AD plus CD. Okay. And AD
Okay.
plus CD, AD plus CD is what? The total length AC, right? This length plus this length is equal to this length. Yeah. So
Yeah.
this is AC into AC. AC plus CD, AD plus CD is this length, AC. So it becomes AC into AC, that is AC square. Now, if you look at this in this equation, what has happened is this is A, B, C. This is AB, this is BC, this is AC. What has happened? Here, what we saw was, oh, sorry, I cleaned it up. So, what we found was AB square plus A plus BC square equal to AC square. Now, AB is what? A, this is B, and this is hypotenuse. So, this is what our Pythagorean theorem says: A square plus B square equal to C square. Okay. So we proved that Pythagorean theorem. Now you will say that you proved it in a very complicated way. That is how it makes it worrisome. And you would think that no, we don't remember anything. Now let's look at what we did, and that is what will make it simple. Okay. So what we did was this: we took a right angle triangle, yeah, and then we have drawn a perpendicular line from this corner to the opposite side. Okay. So that is what made us get two small triangles ABD and BCD. And then when we looked at the angles, we found that the small triangle ABD and the other small triangle BCD, they are similar to the parent triangle. So when the triangles are similar, the ratios of the opposite sides for the matching angle are in the same proportion. So between the large triangle ABC and the triangle ABD, this is the formula we got. This is the based on the property. Likewise, the triangle ABC and triangle BCD, they were also found similar because the angles were common. This was 90 degree, third angle was matching. So this is what we got. So based on this, we just took the formula out, and these are the formulas that we got. What we did was we took the ones, this one, this and this one, okay? This one and this one, these two pairs we took. Wherever we had the full length size of or no we picked the ones where we had the main parent triangles no sides actually. Okay, we looked at this formula, and that is what got us this. So we took this one, this one, this one, and this one in the two, and that became our next formula to look at. So I okay, let me do it one more time. So can you guys write it down? So this was the original triangle. We just had drawn a perpendicular line, and that got us two triangles like this based on the similar triangle, and we that kind of got us the similar triangles. So this triangle was similar to the parent triangle. This triangle is also similar to the parent triangle. So based on that, we looked at the formula of the similar triangles, or the property of similar triangle, which says if the two triangles are similar, the sides opposite to the matching angles are in the same proportion. So that's what we did. And then we picked up this combination and this combination. Okay. You'll say, why did we not pick up this one?
I
This
I
one.
have to kind of go.
Okay. That's fine. So basically, just doing a recap, we picked this formula, this combination basically, and then we simplified that. That is what got us this theorem. Okay.
Okay.
So we'll watch this one offline, and I'll again do that in the class tomorrow. Okay, when we meet in person, and we'll just make sure that this part we are clear with that. Okay, concept is very simple. You have to find similar triangles. I I just stopped the recording. So